Welcome to Chip Chat Conversations in the Cloud, a weekly podcast with IT leaders who are driving the future of a software-defined infrastructure-based data center.
Hello, I'm Gary McCulley, and welcome to Chip Chat Conversations in the Cloud. Today I'm speaking with Bernie Wu, Chief Business Development Officer at Levyx. Good morning.
How you doing, Gary?
Doing well, thank you. Tell us a little bit about Levyx.
Levyx was founded in 2013 to enable real-time persistent computing for big data. And that's all about shortening the time to value for running big data workloads. And the way we're doing that is by providing a new type of system-level software-based storage and analytics engines that will allow existing and new applications to run faster, cheaper, and simpler using state-of-the-art commodity hardware.
Tell me a little bit about real-time persistent computing for big data. What does that really mean? Boil it down for us.
Yeah, so for us, real-time means really the need to reduce both latency for both storage latency and compute latency. And by doing that, we improve time to value for end users for both batch and streaming operations.
Tell us why latency is so important, for example, in big data workloads or NoSQL. Why is the need to drive latency down or increase performance so important in those workloads in particular?
Yeah, so I'll give you an example out of the financial service area. There's an outside research firm that does validation testing called Stack Research. They oversee benchmarks in the financial service trading area. And what they're seeing in that area in particular is that latencies have been dropping about a factor of 10 every 3 years. And having trading algorithms and trading systems that can keep up with that latency reduction is a competitive advantage.
Talk about the gap between some of the newer hardware technologies, for example, our Intel Optane drives, and the big data universe. What innovations are we doing to bridge this gap?
Yeah, so most of the big data NoSQL database architectures can be traced back to a white paper published by Google back in 2006. Which at that time described scale-out architectures using commodity servers. Today, if you look at a modern commodity server, very common to see a couple dozen cores, very common to see 128, 256 gigs of RAM. They're equipped with PCIe. They have now NVMe flash drives, and also Optane is coming out this year. So the hardware has made tremendous advances, but the software layer hasn't kept up, and that's where Levyx is going to make a difference.
Okay. How does Optane fit into all of this?
So we actually done some comparative work using flash drives, P3700s from Intel, and then also we've taken a look at the Optane drive. And we see the Optane drive running at 3 to 4 times faster than the top-of-the-line P3700 flash drives. So, for example, with our key value store called Helium, we can get about 20 million operations per second using Optane, and using P3700, we get about 5 million operations a second. The other good news for things like operational trading and things like that, analytics, is our latency distributions are much tighter. So our 99 percentiles on latency are 20 microseconds on Optane versus maybe 150 microseconds on a regular flash drive. So we're seeing a 7x reduction in latency distribution and almost a 4x increase in performance.
That's great. Are your offerings mostly software products?
Yeah, we're all about software. So we're system-level software. So one of the innovations that we've done is most database storage engines today currently run on top of a file system, on top of the volume manager inside of a Linux operating system. We bypass all those layers as part of our effort to drive out latency and then talk directly to the devices, and we have built a whole new architecture that takes advantage of parallelism in modern servers. So again, the modern server today has many cores. We will create a multi-core, multi-threaded key value store that leverages all those cores. On the same angle, the flash side also moved from a single-channel device like a disk drive to a multi-channel device like Flash or Optane. So we can take advantage of the multiple I/O queues within flash systems to get a high degree of parallelism between the storage layer and the compute layer. And with that parallelism, we can now create what we call a persistent storage class memory architecture using either RAM plus NAND flash or Optane itself.
You have 3 products, right? Helium, Xenon and Levyx Spark Connector?
That's correct. So the Helium is a basic key value store engine that's embeddable that we would offer to software developers or OEMs that want to have a high-performance key-value storage engine built into their application. This could be used for streaming applications, indexing, for message architectures. So that's one product, Helium. And it currently runs at least 10, sometimes 100 times faster than existing open-source key-value store alternatives. The second product, Xenon, takes the concepts of Helium and extends that into more of a columnar structure that allows it to be used in conjunction with Spark. On top of that, we're not only accelerating the storage layer, but we're also accelerating the compute layer. If you look at a lot of the modern big data architectures, the compute is actually done out of a Java virtual machine. What we do is we intercept the compute request, the queries in analytics processing, and push that down to what we call bare metal levels within the server and execute those at a much higher speed against this highly optimized storage layer. So we bring the compute closer to the storage, and we also accelerate it along with the higher performance of the storage layer itself. And the third product is the Levyx Spark Connector. And what that does is bridge our Xenon layer to Apache Spark. Apache Spark is one of the most popular in-memory compute architectures out there right now. It's being used for machine learning. It's being used for SQL stuff, R, statistics, Python, etc. And this connector allows us to plug into those existing Spark environments and accelerate existing applications running on Spark, and then also provide something what we call storage class persistent computing. So because we're using Flash, any computations, any work we've done is now persisted in the Flash or the Optane layer. And we find that that unlocks other use cases such as concurrency. So a lot of times customers using Spark will want to be able to ingest data, but then simultaneously have different Spark jobs or contexts running queries on the same data while it's being ingested. And for the first time, we're able to enable that kind of capability for the Spark community.
Talk a little bit about the relationship you guys have with Intel.
Yeah, so Intel's a very close partner of ours. We've been excited to work with them. We're doing a lot of characterization. We are about to publish our test results on Optane. And so we're very, very excited about Optane. It's very much in line with our direction of trying to bring persistent computing to the big data universe. Pretty much when we got our first access to Optane, it was plug and play. So there was no modifications to our code, and everything just worked. So I think that's one message I would say to our customer base is that if you use us, we're kind of future-proofing your move to persistent storage and persistent computing.
That's great. Where can people go to find out more about your company's products and services?
If you want to learn more about us, check out our website, www.levyx.com. And you can read up on us. There's a live benchmark demo running in the Google Cloud that you can observe on our website. We have some white papers, and also if you still have questions or want to evaluate our software, you can send us a message and we can go from there.
Well, that's great. Thanks, Bernie, for spending time with us today. Best wishes and continued success.
Thank you very much, Gary.